Okay, let's get going. I know this cliche gets trotted out in basically every presentation that gets given here at Global Summit. And someone says, I'm the only thing between you and insert next event here, but I am indeed the only thing between you and presentation from the guy who invented Siri, apparently. So I'll try and make this quick and make sure we finish in plenty of time so that we can get out and get changed and get ready for the 6:30 session. So what we're talking about at the moment is choosing public cloud. Let's start with an introduction. Anyone who's been in either of the other two sessions I presented earlier this afternoon, I know some of you had probably heard the introduction before, but I'll run through it again for the benefit of the new joiners. My name is Wright. I'm a member of the technology architect team here at InterSystems. We're a small team, 5 people in total. 2 people here in the US, 1 on the East Coast, 1 on the West Coast, 2 in Australia, and myself based in Scotland. And I primarily work with our customers and prospects in the UK and Europe. The technology architect team, our role is to define solution architectures for all of InterSystems products. That's InterSystems Iris, HealthShare, our other data platforms offerings, and for TrackCare. So we work across all of those products. And what we're doing, as I said, is defining technical solution architectures for all of those products. So we're concerned with things like availability, performance, scalability, reliability, and those kind of things. I've been with the company for about 18 years now, about 12 of those years in sales engineering, first here in the US for 10 years and a couple of years in the UK. I spent 3 or 4 years working in our TrackCare, with our TrackCare product in technical product management, and I've spent the last 3 years in the technology architect group. So that's me. What about the session? Well, today we're going to talk about 3 things. We're going to discuss in a little more detail than we did in the previous session adoption of the public cloud. We're going to talk about who the major public cloud providers are, and we're going to consider the criteria that you can use to evaluate them if you're going to move into the cloud for the first time. Okay? So does that sound like the session that everybody thought they were signed up for? Yep? Cool. Then we'll keep going. Okay, so public cloud adoption, and I'll admit I've taken these figures from what is the de facto standard description of this every year, the RightScale State of the Cloud report. It's, I say, very authoritative, very thorough survey of what's happening in the cloud year on year. I've included a link to this year's State of the Cloud report in the bibliography section. But these figures come from there. Nearly every enterprise they survey now uses the public cloud in some way. So 96%, that's practically everybody, I think. So this isn't a niche thing anymore. It's very much mainstream. Of those, almost a third see public cloud as their top priority. So of all the things they think about, a third of these enterprises consider public cloud to be the most important one. Depending how you measure it, somewhere around about 40% of workloads are running in the public cloud now. And public cloud spend is increasing. So these numbers I kind of had to read them more than once to make sense of them. It's a lot of money, okay? So half of all the enterprises they surveyed, and by implication half of all enterprise, each spend more than $1 million a year on public cloud computing. That's an awful lot of money. Within that use of public cloud, one of the emerging trends is much more use of configuration tools, Ansible, Chef, Puppet, and so on, and more usage of containers and container orchestration tools like Kubernetes. And as you'll have heard me say in the previous session, if you were here, what are people worried about when they think about public cloud? Their biggest concerns are security and the amount of money they're spending. And security is by far the leading worry, if you thing they're concerned about if you look at the survey results. Okay. Recap this, if you weren't in the previous session, cloud service models, there are 3 of them. They were defined in a paper published by the National Institute of Standards and Technology in 2011. It's called the NIST report on cloud computing. It's available online if you're interested in reading it. They defined 3 types of service model for the cloud: infrastructure as a service, platform as a service, and software as a service. Start from the lowest level and work up. Infrastructure as a service is the idea that the cloud provider will provision virtual machines, storage and network for you. You're going to pay for them. You're going to manage things running on them for yourself. If you move up a level, you've got platform as a service. Platform as a service is the idea that they're going to manage those things for you. So all you're worried about is developing, deploying, and supporting your software on top of that platform. And then the outermost wrap there is software as a service, where someone, yourself or somebody else, has built an application, they've deployed it in the cloud, and you are using it on a service basis. Good example of this, the ones that were talked about in the keynote this morning: health share as a service and connectivity as a service. Okay. There's another range of things that weren't covered by the NIST model. Sorry, just should have said those 3 things together: infrastructure as a service, platform as a service, and software as a service, are collectively referred to as the SPI model. Okay, acronym of acronyms. Okay, as said, there are a range of things that the guys who wrote the NIST report back what seems like a long time ago, but was 2 World Cups ago, for those of you who measure your life in World Cups, was not really very long ago. What's generically referred to as anything as a service, XaaS. Within that, there are all sorts of things available. 2 things from InterSystems that we just talked about: containers as a service, DR as a service, monitoring as a service, network as a service, and so on, and so on, and so on. The range of these is limited only by the number of acronyms that are available to describe them. So that's the model. If you want to deploy in that model, who can do that for you? Well, there are really 3 dominating providers in the public cloud market. They are, I'm sure you're all aware, Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, or GCP. They're not the only ones in that marketplace. There are other competitors, and those competitors can be local in geography, or they can be niche in their offering. The important one, the one that's really the 3.5th, if you will, major provider, are Alibaba. Alibaba were originally in the Southeast Asia market in China. They are trying to expand out of that market by opening data centers around the world. So they may or may not make that leap from being the 3.5 to the 4th over time. On top of that, there are other smaller, specialized niche providers. They provide things like what are referred to as community clouds, where they're specifically tailored to a particular type of industry and those kind of things. And as we'll talk about towards the end, most companies now don't adopt a single cloud policy. So it's very rare it's relatively rare these days for an enterprise to be deployed just in AWS or just in GCP. The majority of companies now are actually multi-cloud, and we'll talk about why people want to do that towards the end of the presentation. Again, if you're in the previous presentation, you've seen this. This is the Gartner Magic Quadrant for cloud providers. As you can see, those 3 that we already talked about, AWS, Azure, and GCP, are the ones that are in the leadership quadrant. Another way of looking at that is market share by spend. So if we figure out who's the biggest in terms of the money that's being spent with them, well, it's important to note, or it's interesting to note, that the overall market is huge and continuing to grow. As was mentioned this morning, somewhere around 200 billion this year. I mean, Gartner says 186 billion of cloud spend this year, but I mean, what's 14 billion a year between friends, I guess, and growing at a significant rate. So 25% plus, well over 300 billion US dollars by 2021. So it's a ton of money that's being spent out there. AWS is the market leader. They were first to market. They're still the market leader. They have around about a third of the market share, and the best estimate is they grew by 48% into this year. Azure is next. They have about half of the market share that AWS do. So AWS about 34%, Azure 16%, but they're growing more quickly. And then GCP are in third place, again, around about half of the share that Azure have got, but they're growing quickest of all. So you'll see these figures kind of level up, I think, over time. The smallest provider out of the three is growing the quickest, and the largest provider is growing the slowest, but they're very far, they're very, they've got a big lead, so it's going to take a long time for everybody else to catch up. It's worth making the point that most of this growth is not one vendor taking business from another. So Azure isn't growing because they're taking market share from AWS because they've got a better offering. What's happening here is that our overall market is growing quickly enough that the rising tide is lifting all boats, and each one of them is growing. The smaller ones are growing quicker than the biggest ones, but they're all growing, and that growth is being accommodated by the growth of the overall market rather than redistribution of market share within it. And as I said, Alibaba, again, if you keep halving, you go from GCP at 8 down to Alibaba at 4. I'd be tempted to think these numbers were made up. They make such a nice progression, but I assure you that as far as we know, they're good numbers. Alibaba's important because it's got a 4% share globally, but locally in Southeast Asia it's much, much more. And they're now attempting to go beyond that and become a global player. And so we'll say, well, those are the big 3.5, possibly 4 in a few years' time. Who's going to be next? Is there going to be a next competitor? And I think probably not. I think that's the market now. And why is that the market? It's because there's been so much money invested up to this point that the cost of entry for another competitor is going to be prohibitively high. So to compete with AWS, to compete with even the people right down at the niche end of the scale, requires an investment, a huge investment in infrastructure and services. And now that bar's probably set too high for anybody else until there's a paradigm shift for anybody else to come and compete in the same way, I think, but we'll see. Okay. Another way of thinking about usage of the public cloud is by workload distribution. Again, same figures as from the last presentation. About a third of all workloads running in the public cloud. Somewhat surprisingly, more than that running in private cloud, and we'll talk about what the difference is. And then there's that segment of the workloads that are not yet or not ever going to move to the cloud. Now, I think that number's going to fall, that 23%. It's going to fall for a couple of reasons, as we talked about in the last session. There's a group of applications that it doesn't make sense to run in the cloud because they don't fit the model. And also, the overall pool's getting bigger, so even if that number of applications stays the same, as a percentage, it's going to drop. But I think we're going to see those numbers staying in the same ratio roughly, but growing in total volume. Any questions about any of that before we go on to talk about the individual cloud providers? No? You look like you're tempted. No? Okay. AWS. So AWS are the market leader. They were first to market in 2006, and they've been the dominant player since then. They offer a full range of infrastructure as a service and platform as a service capabilities. Within their data centers, they used to run on a hypervisor based on Xen. Since 2017, they've been moving to a KVM-based hypervisor, but modified for their specific requirements. And they really lead the field in enterprise scale adoption. So we talked about the number of companies that spend more than $1 million a year. Well, AWS have a significant number of companies who spend more than $5 million a year with them. So that's a lot of money. But they also have a smaller number of customers whose annual spend with them is in excess of $100 million. So they've got a significant number of people spending $100 million or more with them every year. So it's a lot of money being poured into that. Because they've been around the longest and because they are the largest, they have the richest supporting ecosystem. So they have more service providers, more components, more applications, more consulting partners than any of the other cloud service providers. If you go onto their portal, their website, you'll see that they list over 2,000 accredited, with accredited being an important word, consulting partners offering managed services and professional services. They have the marketplace for third-party software that has more than 5,000 items listed. It's very difficult to count them because it scrolls on. I know it's more than 5,000 because I got bored counting at 5,000 and stopped. And I wasn't even a significant proportion of the way through. And as was talked about this morning, within that marketplace, InterSystems Iris will soon be in that marketplace as well. That's not to say you can't deploy InterSystems Iris on AWS at the moment. You can. It just means that there's a different way of provisioning it once we get it into the marketplace. It's one-click provisioning rather than provision the VM and then install Iris. Okay? And how do they market themselves? How do they position themselves? Well, what they're going to emphasize is the fact that they have been around the longest. They're the most reliable, they're the most stable, and they have the richest ecosystem. So that's their USP, if you will. Okay. Talk about their offerings. Once you start researching AWS, you'll come across EC2 very quickly. EC2 is Elastic Cloud Compute. It's AWS's way of providing compute services to you. By default, these come with things like auto-scaling and auto-replication. So if your resource is becoming overused, they'll scale it up for you. If you want a second copy, they'll take care of that for you, and so on. If you don't want to do virtualized resource, you can also provision bare metal from them. They also have that as part of their marketplace. Sitting behind that, they have all different types of storage tailored to meet your particular need. And as I've said, there's a complete catalogue of additional capabilities sitting behind there. So there's, as I've said, hundreds, thousands of these. Before I talk about them, I'll just mention that the cloud marketplaces, the AWS, Azure, and GCP cloud marketplaces, are an almost perfect example of a convergent market. Because if someone comes up with something that's innovative, someone comes up with something that provides a service that people need, you'll very soon see it replicated, typically under a different name, but in the other cloud market, other cloud providers' marketplace. I'm sorry, it's the third session I've done this afternoon. I'm getting a bit tongue-tied. So it's a convergent market. So I've just picked some things out here that you kind of interesting from an intellectual perspective. So they have something called CloudWatch, which is their monitoring service. They have something called CloudFront, which is a content delivery network backed by their storage. They have container support in various different flavors. So they have a type of container support where you provision virtual resource and then you run containers on it. So you're provisioning a virtual machine and then you're running a container on it. They have a type of container support where you don't work at that level. You work at the Kubernetes, the orchestration level. So you work with a Kubernetes template or formula, and then that turns into container resource. And then they have another one, their latest one, is this idea called Fargate, where you don't actually get into defining what you want the container to, how you want the container to run. What you define is how you want it to behave, what you want it to do. And they then take that definition and provision it somewhere and run the container for you. So a broad range of different ways of supporting that. They have this idea of serverless computing. Their offering is called Lambda. They have an orchestration service, Elastic Beanstalk. I've only included that because I like the name. I think it's quite a good one. And they have a tight integration with VMware on and off premise. So they have this idea that you can migrate your VMware workloads into AWS and then back out again. And as I've said, and so on, and so on, and so on. Okay. AWS Locations. So it's important to remember that at the end of the day, what we're talking about with cloud service providers is just data centers. It's just data centers that they own, they manage, and present the resources within in a particular way. Okay, so there's nothing magic happening here. At the end of the day, it's just a data center. But you're probably concerned about where those data centers are because you need to make sure your system is available in the case of a data center failure. So they organize these things into regions and what they term availability zones, or AZs. Each region contains multiple physically separate AZs connected by low latency network, although they don't latency bound the regions like some other cloud providers do. And they currently have 18 regions and 55 AZs around the world, including, then they're not the only one to do this, they have a dedicated US government region called GovCloud, which meets US federal restrictions about security and so on, and that's where government resources, government systems can be deployed. If you look at the distribution of them around the world, we'll look at this map for all the cloud providers. It's pretty much the same for everybody. So there's always a heavy concentration in the US, there's a heavy concentration in Europe, and there's a concentration in the Far East. So everybody does that, and then they'll provide outliers in other areas. So in this case for AWS, they've got locations in Australia, and they've got locations in South America. Any questions about AWS before we move on? Okay. Next in terms of market share is Microsoft Azure. So they entered the platform as a service market in 2010 and the infrastructure as a service market in 2013. And they've now matured to the point where they offer, again, that full range of IaaS and PaaS services. They differ in that they're eating their own dog food and running their own hypervisor in their data centers, so they're using Hyper-V in the data centers. They also have a marketplace for third-party software and services. InterSystems Iris is already available in their marketplace, has been since last week, I believe, so a relatively recent addition. And how are they going to market themselves? Well, they present their key strength as being the integration and leverage of Microsoft capabilities. It's very much a Microsoft-oriented solution. So if you're heavily invested in Microsoft, in the way of working in their products, this is probably going to be the best fit for you. So what do they offer? Well, they don't just offer Windows VMs. They offer Windows and Linux VMs. They offer, again, all sorts of different types of storage depending on what you need. And again, that extensive catalogue of additional compute capabilities. And again, I've just picked some out, but remember this is a convergent market. So what one offers today, the others will offer tomorrow. Scale sets for managing multiple VMs. Container orchestration. Again, like we talked about with AWS, they call it AKS, Azure Kubernetes Service. Again, serverless computing, they call it functions, similar to AWS's Lambda. They have the orchestration piece, they call it Service Fabric. They have a very strong AI offering, it's called Azure Batch AI. They have monitoring, and so on and so on and so on. So the things that we picked out from AWS, you can find the similar things in Azure and GCP, and vice versa. Okay. One thing they have that is a bit of a differentiator is that if you think, geez, what I really need to solve this week's business problem is a little supercomputing, they can help you. So if you need supercomputing, if you need a Cray, they'll make one available to you in their data centers. I'd love to meet somebody who's done this. I haven't yet, but if anybody does, if anybody gets to the point where they think, geez, I really need a Cray, please get in touch. I'd love to hear about it. Okay. In terms of locations, they again have this concept of regions and zones. They add an extra layer on top of that. They talk about geographies as well, and that's the idea that similarly a region and zone are data centers grouped within relatively latency-bounded networks, so they define these in terms of the latency between them. They had this idea of a geography, and a geography is a group of two or more regions. that preserve data residency and compliance boundaries. This is important in some locations. In Europe, for example, there are very strict laws about where data can reside and how it can move across national boundaries. So if you have sensitive data, if you have patient-specific data, it can't move freely across national boundaries. So this idea of a geography might be important to you. If you want to replicate data between two regions, you can do that within a geography with Azure. You can do it with AWS and with GCP too, but they don't provide that kind of pre-built container for it that Azure does with the geography. As again, the AZs, they don't call them AZs, they spell it out, availability zones, separate locations within a region. And if we look about where they're created, I apologize, this is rather difficult to read, and the projection is not easy to see. It's a different type of map projection. But again, you'll see there's a heavy concentration in the US, there's a heavy concentration in Europe, and there's a concentration in Southeast Africa. Azure have more of these outlier locations than the other cloud providers, so they're the only ones with a presence in Africa, both in terms of South Africa and in the Horn of Africa, and they're the heaviest presence in the Indian subcontinent too. Bless you. GCP, Google Cloud Platform. They entered what they term the APaaS, Application Platform as a Service market in 2008, and the Infrastructure as a Service market in 2013. And their basic offering is IaaS, they refer to as Compute Engine, and APaaS, as they refer to as App Engine. But they now have that full breadth of offerings too. So they have all the IaaS and PaaS capabilities that the other providers have. Again, they're using an open source based hypervisor, they're using KVM. It's noticeable, they have a marketplace similar to the other ones. They have InterSystems Iris in that marketplace. That was the first marketplace we were in a couple of months ago. But it's noticeable if you go and look at their marketplace that it's not yet as extensive as the other providers. There aren't as many third parties in there aren't as many tools in there. I'm sure it will catch up relatively quickly, but at the moment it's not quite as extensive. And how are they going to position themselves in the market? Well, they're really positioning themselves based on a couple of different things. They're leveraging the capability of Google to innovate. So what they're saying is, if you want to tap into all the cool stuff that Google is doing, this is the platform to be on. And if that doesn't work for you, they're going to say, and we'll cut you a pretty good deal too. So they tend to be very aggressive on pricing as well. Okay. So in terms of offerings, what do they have? It's basically the same set of stuff as we've said, with a different set of names. As we've said, it's IaaS is Compute Engine, and the Application Engine they refer to as App Engine. And again, they have the container orchestration piece. They have a container registry for your Docker containers. They have all different types of storage. I'll bore you by reading them out. And so on and so on and so on. So again, it's a convergent marketplace. What you'll see in one, you'll see in the other. Okay. In terms of locations, they talk again about regions and zones rather than availability zones, but it's the same concept. And again, they're talking about regions being independent, containing zones, and locations within the region having a latency bound on them. So the question you had earlier about what's the maximum latency, well, these are the people who are guaranteeing that's what your latency would be within that region. Okay. And zones of single failure domains. And again, if we look at that distribution, again, it's a different map projection, and it's much more clearly labeled this time, but again, heavy concentration in the US, heavy concentration in Europe, quite a lot in the Far East, quite a strong presence in South America and Australia, but if you want to do it in Africa, you're out of luck at the moment. Okay. So how are you going to choose between them? Well, it's important to say that there's no kind of standard way of doing this. Typically with these kind of evaluations, there's a checklist you can find somewhere and you go through, tick the boxes, and away you go. I haven't ever seen or been able to find anything that encapsulates or encodes that for you. So you're going to have to put your own together, and you're going to have to make considerations across business, technical, and operational requirements. And your specific criteria are going to be driven obviously by your own business case, but they could include security, standards and compliance, architecture, technologies and services, manageability, service levels, support, and ecosystem and tools, and finally costs and commercials. I'll run through each one of those very quickly. Security, as we've said, security is the number one concern for people in the cloud. For people who are thinking about moving to the cloud, and also for people who are already in the cloud, security is that biggest concern. How do you figure out if the cloud provider is a good fit for you? Well, first you need to understand what your security model is. Okay? What security features do you need, and then what's provided by the cloud provider, and can you use that in a way that can build out the security model you want to? Each cloud service provider publishes something they'll call their shared responsibility documentation, and this is the thing that sits behind your contract with them that says who's responsible for what in terms of security, who needs to take care of what, and that's the thing you have to make sure supports what you need. Okay? And the key things to understand from reading the shared responsibility model are what security features are provided out of the box, so what comes as standard, what's available but costs you more, and then what you'll need to get from a third party. So those are the three categories I'd put those security features into when you're evaluating. Standards and compliance. If you have particular standards or levels of compliance that you need to adhere to, things like HIPAA, GDPR, PCI, those kind of things, make sure your cloud service provider can meet that requirement. As we've said before, location of data may be important. So if it's part of your business requirement, you can't move that data across national boundaries, make sure that your cloud service provider can accommodate that. So if you need replication between regions, make sure you can do that and keep within the geographical constraints you have. And again, rather than compliance that you need to provide, what does the cloud service provider do? There's a whole range of these across infrastructure, across security, across operations. There are as many frameworks and standards as you can think of, really. If there are any that are important to you, go to the cloud service provider's website. You'll find these all listed there, all of the standards and frameworks that they adhere to. So if there's one that's key to you, make sure it's on their list. Architecture, technologies, and services. Does the architecture that the cloud service provider is going to give you fit with what you want to do, with your workflows, with your workloads and your objectives? So some things you might consider here are, do you have a significant investment, either now or in the future, or are you going to make a significant investment in a specific technology? If you do, is it a good fit or isn't it a good fit for the cloud provider's model? Similarly, do you have an investment in licenses? And if you do, can you or can't you move them into the cloud? Your mileage is going to vary based on this, but these are things you might want to think about. Are migration tools and or services offered by the cloud provider? So do they have automated ways of helping you migrate workloads into the cloud? If what we're talking about here is that lift and shift infrastructure as a service migration, do they have a set of tools that that help you to do this? And do you need to engage third-party help? And if you do need to engage third-party help, who's available? How are they accredited? What track record do they have? And it's important to bear in mind that many tools, including InterSystems Cloud Manager, are cloud agnostic. So you might want to move up a level and think at that kind of meta layer, meta definition, rather than the specific cloud provider's offerings. And you'll also want to review the available reference architectures. Again, apologies for people who were in the earlier session, but we do publish reference architectures for the big three cloud providers. That's one for Amazon AWS. That's one for Microsoft Azure. That's one for GCP. They're all different, obviously, because they're all tailored to the specifics of that cloud provider's offering. They're going to give you a starting point. They're going to give you a starting point for an informed discussion with the cloud provider and with us. Okay, so when you talk to your sales engineer, when you talk to the local technology architect, this is kind of the starting point that the point we'll be starting from to move that discussion on to something that's specific to what you need. Okay. Manageability. What's the overhead associated with moving to this cloud provider? How frictionless or frictionful is this move going to be? Orchestration tools. Do you use them? Are you going to need to use them? If you use them already, are the ones you use already supported in that cloud environment? Are there any particular services that you think you're going to need to build or enhance your application? How are they provided and supported in that cloud platform? Okay. Service levels. Okay. Make sure that the provider's SLAs align with your business needs. The SLAs are the contractual obligation that the cloud service provider has in terms of availability and service that they're going to give you. Okay, make sure that they will be legally enforceable, but make sure they meet your business model. And again, stress the point. Make sure that if you've got any geographical constraints, make sure that they are also legally backed up and clearly defined. If your data goes missing, if your data crosses a national boundary where it shouldn't have, you don't want to be the one who was at fault for that. Okay? You don't want to be in that situation at all, but if you are, it's better that it's the cloud service provider's mistake and a transgression of their contractual obligation rather than you making a mistake. Okay. Support. It's important to realize here that cloud service provision is a high volume business, okay? It's high volume, low touch business. And within that pool, as we've already said, there are a significant number of people who are spending in excess of $1 million, $5 million, or even $100 million US dollars today. So if you're just getting into that market, it's very unlikely that you're going to be working at that level of spend, at least within the foreseeable future. So you're probably going to be somewhere near the bottom of the totem pole in terms of support and how it's delivered. Often it's going to be an FAQ page or a helpline, so it's going to be somebody who doesn't really understand your application. They're basically following a set of prompts. Is that enough? Is that good enough? If it's not enough, what else can you do? Well, you can probably pay for extra support. Is that available from a cloud service provider, or do you need to go to a third party for that? Again, factor that into your calculations. And again, the ecosystem, how rich is it? Is there an accreditation program, or is it just a free-for-all? Okay. If there's an accreditation program, it will be very heavily advertised because people like AWS see it as a differentiator. Although it's important to note that back when there were 20 or 200 even people in the AWS accredited marketplace, I kind of think it meant something. With 2,000 plus, what level of accreditation can they really be doing on all of these people? So I think as that number grows, the value of the accreditation kind of diminishes, but take it at face value and see what value it adds for you. Okay. So as we've said, each provider has that online marketplace. Cost and commercials. It's important to think about the total cost of ownership. So there's obviously the direct cost of the cloud infrastructure, but then there's the cost of either retraining or employing new staff or employing third parties to do some of this work for you. All of the cloud providers have a degree of free-to-use evaluation options, and you can do quite a lot there. So if you're considering moving to a particular cloud provider and you're interested in getting a feel for how the environment works, what the friction is involved in moving there, what the overhead is, how the moving parts fit together, absolutely try these out. You need to sign up for an account, and then you'll get either some time-constrained or resource amount constrained access, and you'll be able to kind of start things up, shut them down, deploy things and so on, and see both in terms of deploying your application, but also in terms of how the different moving pieces fit together, whether it's going to be a good fit for you. It's important to note that, like with buying anything else, there's a sticker price and then there's the actual price. Typically, the sticker price can be reduced by buying in a couple of different ways. You can either commit to a lot of something or the same amount of something for a long time. So if you're buying 1,000 VMs, you're probably going to get a better deal than if you're buying one. And if you're saying, I need this VM for 5 years, you're going to get a better deal than saying, I need it for 5 minutes. So be cognizant of what your actual overall model is and make sure you get the appropriate deal based on that. Pick the right usage model. So by default, it's metered usage. You pay for what you're using while you're using it, but that's not the only model that the cloud provides. Okay? There's something called spot use, which can be quite useful if it fits in with your business needs. Spot use is where you say, this is the workload I want to run, and this is the price I want to pay for running it. And each of the cloud providers has a spot market of available resources, and what they're trying to do here is leverage their resources as efficiently as possible. So they want to utilize their compute whenever they can. So they'll price that based on demand, and there'll be a spot price for the use of that compute. If that spot price falls below the threshold you've set, they'll run your workload. So you tend to get it at the cheapest price, but it won't be a predictable time. So it could be, it runs in 5 minutes, it could be runs in 5 days, 5 weeks, whatever. So if that fits your business model, that might be a good way of doing it. The other end of the spectrum is what's called reserved use. So in the idea of metered use, this is typically your cloud first way of thinking about things. I'm going to use something, I'm going to pay for it while I'm using it. When I'm not using it, I'm going to shut it down and move on. If you're deploying a legacy, a mode 1 type application here, you're typically not going to be working in that model. You're going to say, I'm going to run this, and you know it's going to run for a lengthy period of time. So in that case, reserved usage might be the best model for you, where you commit to running this resource for a significant period of time. And again, understand the level of granularity you'll be charged at. If you're running in a metered use environment, are they charging you for every second, or are they charging you for every hour? AWS round up usage to the nearest hour. So if you're running things that only take seconds or minutes to run, you could end up paying for a lot of compute that you're not actually using. Okay? There are a lot of tools that are available for calculating the upfront costs. So there's lots of opportunities for doing a compare and contrast on these. Each cloud service provider has their own calculator, and then there are some very good third-party tools where you, again, work up that meta layer, you define the type of resource you want, and it will cost it for you across the different cloud service providers. And it's important that once you've deployed in the cloud, you keep an eye on your cost. So there are lots of different ways you can cost optimize. Again, because it's a metered service model, typically, you only want to be using what you want to pay for. So you want to keep your resource requirement as small as possible and manage that dynamically and aggressively. Again, there are lots of tools available to help you do that. Bottom line is, though, it's probably going to cost you more than you expected up front. There was an expectation or a misconception that cloud computing was going to be a cheap way of providing resource. It's typically not. A properly configured, properly managed, highly available cloud platform is typically no cheaper than running in any other model. Okay, so be aware of that and manage your costs accordingly. We talked about types of workload a couple of times, and the type of workload that you're running requires different evaluation criteria. Again, using Gartner's bimodal IT differentiation, there's this idea of mode 1 reliable workloads. They're typically reliability and efficiency oriented. These are the ones where you're going to do a lift and shift into an infrastructure as a service model. There's the type 2 or mode 2 agile workloads, cloud first, cloud native. These are agile and innovation oriented and less predictable demand. So obviously the model you use for evaluating is going to be different if you're building one of these as opposed to building one of these. If you're building one of these, you're committing to long-term resource usage, a predictable level of performance, and you'll need to cost accordingly. if you're deploying a Mode 2 Agile application, it's typically going to be leveraging all those cloud characteristics we talked about, and it's going to be running in a cloud-friendly model. So it's going to be a much better fit for that cloud model that we talked about. So you'll be able typically to manage that much more aggressively in terms of the resources you're using. Finally, we'll talk about multi-cloud strategies, and surprisingly to me, most companies who are deployed in the cloud now are now multi-cloud. It varies depending on whose numbers you believe, but 70% or more, depending on whose numbers you believe, are now multi-cloud rather than single cloud. Why might that be? Well, it might be that you want to do a best of breed across cloud. So you might think that one cloud provider's AI is better than another, so you use AI in one cloud, but you use Elastic Compute in another cloud, or containers in another cloud. So you're differentiating between the offerings of the cloud providers and saying that's the best one for that, that's the best one for that, that's the best one for that, and doing best of breed. That's one reason to do it. Another reason to do it is just plain and simple avoid vendor locking. You don't want all your eggs to be in the AWS basket or the Azure basket or the GCP basket, and that's a very valid way of doing things. You typically negotiate harder on price if you're not locked into one vendor. Increased resiliency. Cloud platforms fail. It's not a case of if, it's a case of when your cloud platform will fail. How gracefully that's handled depends on the cloud service provider and how you've built availability into your system. But I mean, last year, Amazon's AWS's East Coast 1 region failed for 5 hours, and everybody using that was affected. Even Amazon were affected. It turns out that they hadn't followed their own best practices and made their own systems highly available. So all the data, all the icons they needed to drive their availability dashboards were no longer available because they only had one copy, and it was on the storage that had failed. Yeah. So it's resiliency 101, but they got it wrong, and companies like TripAdvisor got it wrong. They were out for 5 hours, and tech companies like Git and Slack and the Docker registry also were affected. So the resiliency guidelines are out there, but they're not always followed. One way you can really belt and braces that is resiliency between clouds. So don't replicate from one region to another, replicate from one cloud to another. Just as valid a strategy. Cost optimization. It might be that some things are cheaper in one cloud provider's offering than another. So you might want to say, okay, I'll do my AI over here, but I'll run my long-running workloads over here because I'm getting a better deal than that. And then finally, and somewhat counterintuitively, a lot of companies who adopt a multi-cloud strategy do it because it drives efficiency, or they say it drives efficiency. That doesn't sound right. As if you're managing multiple clouds, you've got multiple people to deal with, you've got multiple deployment scenarios, it would seem less efficient. But what they're actually doing is moving up a layer. So they're moving up and adopting a cloud-agnostic tooling strategy, which means that they work at a meta layer, and then they have a set of tools that turn that definition into a particular cloud service provider. So they'll say that by being multi-cloud ready, even if they're not multi-cloud deployed, they're more efficient. This is obviously the idea behind InterSystems ICM 2. We want to work at that meta layer too, so you work through a definition file, and behind that definition file we can use Kubernetes and Docker containers to turn that into a set of API calls that are specific to each of the cloud providers. Okay, so that's the end of the presentation. How are we doing for time? Not too far over. If you've got any questions, feel free to ask them now. Feel free to find me or one of my colleagues, one of whom is at the back of the room in the Technology Architect group. You could have let me finish the spiel. No, go on.
I was going to ask, we were hearing that IRIS supports Docker. Does it support Kubernetes the same way?
Well, it's different. Docker is it's the container delivery mechanism. It's how the container runs. Kubernetes is the orchestration. So if you want to manage your containers, you do it with Kubernetes. Kubernetes is an orchestration tool for containers. And so that's the difference. So, and it's kind of the de facto standard. So you'll notice that all of the providers we talked about have some sort of Kubernetes marshalling. And what it does, it allows you to, rather than manage each container individually, it allows you to define policies that apply to all your containers. Very simplistically, but that's kind of what it is. It's an orchestration tool. So they're not mutually exclusive. One manages the other. So you can have containers without Kubernetes, but Kubernetes without containers probably doesn't make sense. Okay. Find us in the Tech Exchange. Ask a question now. Use the resources that are in here. And I tried to put together a bibliography slide here of all the things we referred to. It's basically just a set of links that will take you direct to the marketplaces, the landing pages, and the calculators for you to get started. Other than that, got 40 minutes to get ready and get and see the guy who invented Siri. Okay. Thanks very much, and I hope you enjoy the evening and the rest of the conference. Like I say, do come and find one of us if you have any more questions. Thanks a lot.